In this video, I'm going to explain and hopefully give clear examples and real-world examples, hypothetical of course, of the intermediate value theorem and the mean value theorem. Both theorems of calculus that are somewhat disputed in regards to their relevance, just by the fact that they are mainly based on intuition. However, they hold very true and they're very important to understand. And so I'm going to start with the intermediate value theorem. Okay, we're now going to start with the intermediate value theorem. And this theorem, it pertains to a graph, and understanding the graph and understanding how a function works on a graph. And so the first step is we're going to come up with a function. We're just going to call this function f of x. Doesn't need any specific numerical value. So our function f of x. And now we're going to draw a graph. That will be f of x. So here's the graph. Let's make this a little bit bigger. Okay, here's our graph. And on this graph, there is a continuous function. And this function specifically is from A to B. Now, we have A to B so far, so let's write this out. Here's A. Here is B. Okay. So, it's continuous from A to B, and now let's let f of A equal any given point. Let's call it J. So f of A equals J, this point up here, and let's say that f of B equals any point. Let's call it L. Okay, so now we have J and L. So between J and L, there is any point K, and this is really between any of this. So we know that f of A equals J. So let's put a little dot up here for A, and f of B equals L. So let's draw this out. It's just any given function. Okay, that's our function. That's f of x. Now, on this, there's any point K in between J and L. So here's our K. Let's make it right here. And with this K, there exists a point C between A and B. And this point C is everything behind the intermediate value theorem. This point C is where x equals C. Sorry, I'm a little bit tongue twisted. So f of C equals K. So this point C, between points A and B, f of C equals K. It's a very simple concept. It might seem a little bit complicated, but it's not. You'll get it in a second. So any point between A and B, at this point K, there is a value C between A and B, of which f of C equals K. So that's not really that good right there. Let's try that again. It's about right here. So this is C, that's K, dot up, dot over, this point right here. F of C equals K. Great, that's the intermediate value theorem. Now, I'm going to give a real-life example of this, and hopefully it'll be made clear, more clear. Hopefully it already is clear, but this will elucidate the intermediate value theorem a little bit better. Okay, so here is our real-world example of the intermediate value theorem, IVT. So this is an example, and it takes place in a kindergarten class. And in this kindergarten, a teacher, Miss Higgles, is doing an exercise with her class. And this exercise focuses on practicing the alphabet and numbers. These kids are in kindergarten. They're just learning the alphabet and numbers. So each student is assigning a number to their respective initials. Everyone's done this before. For example, one girl's name is Mary Albert Watkins, and her initials being MAW. So yeah, her initials are MAW. So of course she counts out each number that corresponds with each letter, and her numbers end up being 13, 1, and 23. And of course, M is the 13th letter of the alphabet, A is the first, and W is the 23rd. So it's very simple. But one boy is having a problem with this lesson. He's having trouble. And this boy's name is Alexander. And Alex only knows 2 letters of the alphabet, A and Z. So his name is Alex Xander. And people have his whole life have always called him as AZ. So because everyone always calls him as, and his initials are in fact AZ, A and Z are the only letters that Alexander has ever known. And this is interesting. So he knows that he has a middle name, but because he only knows these 2 very iconic letters, the first and last letters of the alphabet, he assumes that his middle name is in fact not a name, but rather a symbol of sorts. So this troubled Miss Higgles, so she decides that she needs Alex to understand that he does in fact have a middle name. When she tells him this, he accepts this new idea, but since he does not know any other letters, he doesn't know what his middle name would consist of, besides anything that would be an A or Z. So, using the intermediate value theorem, Miss Higgles explains to Alex that the activity that the class is doing, the assigning of numbers to letters, is a great way, in fact, to understand that his middle initial exists within A and Z inclusively, and that this can be depicted on a graph. So this next slide is going to show how Miss Higgles taught Alex the intermediate value theorem while communicating to him that his middle initial is in fact a letter, and it could exist within the spectrum of from A to Z inclusively, which in terms of the intermediate value theorem represent A and B. So this is what she wrote out. So he has these possibility of letters from A to Z, and these are the extremes of the function. This is from the 2 points from and to which the function is continuous. So now Miss Higgles explains to Alex that his name as AZ, so A and Z are respectively 1 and 26 in this letter number game that she is teaching her kids in the class. And so f of A would then equal 1, and f of Z would then equal 26. So let's say this is 1 right here, and this is 26. So f of A is 1, and f of Z is 26 up here. So let's say that she then tells Alex that his middle initial is a letter, and it can exist anywhere from 1 to 26 as a, or from A to Z as a letter or a number. And by telling him this, it also teaches him how letters and numbers can be correlated, because he hasn't yet gotten that lesson. So she says to him, let's say that your number is 21. So let's say that it's 21, right up here. This number also on the function, so let's say that this is a function right here. I overdrew that just a little bit. There we go. It is from A to Z, not any further. This function at 21 must have, for 21, must have a corresponding letter from A to Z. That letter is, in fact, the letter U. So, if hypothetically she tells Alex his middle initial was the 21st letter of the alphabet, it would be U. Right about there. And if we draw this up, then it will correspond right there on the graph. And now she tells him, giving him another example, if it is the second letter of the alphabet, if it is 2, then it will also have a corresponding letter, which would be B. And this is the intermediate value theorem through the lens of a real-life experience, a somewhat odd experience, but it is very clear once you grasp it, and it is intuition, the intermediate value theorem. You'll see that with the mean value theorem as well. And now, after Miss Higgles shows Alexander the graphical depiction of the lesson, he understands that because each letter is assigned a number 1 through 26, there must be a letter within that group that corresponds with his middle initial. Okay, that is the intermediate value theorem.